we got some properties of limits here, guys. So we will start with the limit as x approaches c of function f of x. Let's give it an answer BL. Then we are going to do given the limit as x approaches c of a different function, let's call it g of x, and let's give it a value of m. Okay, so on the first one, sum rule, okay, that means addition. If we have the limit, students, as x approaches c of f of x plus, oh, it's not working for me, plus, come on. There you go. G of x, okay? So in this, we can independently, students, find the limit of each function independently, then add them, if that's easier for us, okay? That means whatever the answer is, okay, so limit of f of x as x approaches c, that's going to be L. The limit of f of x, the limit as x approaches c of g of x equals m. Therefore, we can just add the two answers. Difference, we can also subtract them. So it's very similar to the sum. If x approaches c and we take f of x minus g of x, okay, if that's too difficult to find the limit, then find the limit of each one independently, then subtract them. Okay, because sometimes it's easier to do smaller functions. So that means whatever the answer is, we minus 1 from the other. 3, product, that means multiplication. And yes, it also works with the product. If we have the limit as x approaches c of f of x times g of x, then if that's too difficult to find the limit of x approaches c first. This is an arrow. Okay, find one function first, whatever the answer is, then multiply that with g of x. Okay, and since the answer is L, then we just do L times M. And that would be the same for if we were to have a constant multiple. Okay, what that means, guys, if we were looking for the limit as x approaches c of, let's say, k is a constant, such as negative 100, negative half, negative, pi, times our function, then we could just simply take k out, save it on the side, find the limit first, and then multiply. So whatever k is, we can just multiply at the end. Now let's do the quotient. Very similar. Quotient means we are going to divide. So if we were asked to find the limit as x approaches c of f of x and divided by g of x, and it seems too difficult, then take them apart. Find the limit as x approaches c of f of x first, then divide that by the limit as x approaches c of g of x, add parentheses there. So that means the answer that you got independently, then divide each other. And our last one is going to be a power rule, okay? So we have power. When we do the limit as x approaches c of our function f of x, and this function is raised to the p, then we simply do the limit first, find the answer, and take that answer and raise it to the p. Excuse me. That means our answer is L, then L raised to the p. Example 5, assume that the limit x approaches b of f of x is 7, and the limit x is approaching b of g of x is -3. Find the limit of a, b, c, and d. So as you can see, A says the limit as x approaches b, okay, if we were to do the addition of the functions first, so that means the limit as x approaches b, by definition, we can find them independently first, since we don't know what f of x is and we don't know what g of x is. We just have to use our property from above to find the answer. So by the properties that we just got done writing, we can do it apart like this. Well, they said the limit is 7 for f of x as x approaches b, and the answer is -3 for g of x. So therefore, final answer is 4. Box that up. Okay, I want you guys to do B and C after I'm done with D, okay? So similarly with the quotient rule, if we do the limit, okay, all inside of f of x divided by g of x, that is exactly the same as doing it independently, just like this. So if we were to find the answers independently first, which we do have, okay, the limit as x approaches b of f is 7. Limit x approaches b of g of x is -3. Let's put them together. So 7 divided by -3. I normally don't like that negative in the bottom, so I tend to move it to the top or with the fraction bar. So if you're going to do with the fraction bar, it should look like this. Okay, this or that is fine. All right, go ahead, do B and C.